But this particular feature in Excel needs to be activated. So here's where we're going to start, folks. We're going to start by going to the Options menu in Excel. So click on that, and it'll bring up this dialog box. And you'll notice that on the left sidebar, there's this area called Add-ins. And I want you, at some point to take some time to look inside here and see some of the things that might already be added in or are available for you in your version of Excel. And I want you to notice that there are things that are probably added in and active. So you see that I have like my PDF maker from Adobe Acrobat, and notice I do have the analysis tool pack enabled and active, the solver add-in enabled and active. And those are like the two pieces. But in order to get solver, you need to activate the analysis tool pack first, I believe. And you would find that down here. So where you would look is inside of Excel add-ins. You hit that go button, and then you'll see this little tool palette, and you want to make sure that you turn on analysis tool pack and the solver add-in to enable these features. Once you have the solver add-in enabled, you will, in your data menu, notice a menu right here, or a toolbar button, I guess is a better way to say it, that will enable solver. And if you click that button when you have a spreadsheet up, you will get an interface. Now, the one that you're seeing on my screen is a commercial paid version, a professional version of solver. And when I was teaching in the MBA programs up at Cardinal Stritch, we would use this in the MBA program for people that were learning how to do quantitative analysis on a managerial level, using mathematics and mathematical modeling to optimize real-world situations in order to make sound business decisions, based on what the numbers are telling us, not what we're speculating is best. And sometimes the numbers tell us things that defy our intuition, and sometimes we have to act on our intuition as opposed to the numbers, because it might be in the best interest of humans versus profit, that type of thing. Now, what this dialog will do is it will allow us to attach to this spreadsheet and solve a complicated set of equations simultaneously and optimize them, where otherwise, if we were to do this manually, we would be spending ages kind of getting it going, because every permutation of the equation can take multiple calculations to figure out whether it's optimal or not. All right, so I'm going to actually back out of the interface here, and I'm going to zero out a couple fields on this spreadsheet, and I want to kind of give you the anatomy of what is happening here. And so the first thing that's happening is this spreadsheet is representing hypothetically a real-world manufacturing situation. So let's set up a scenario. There's a furniture manufacturer, and they have a production facility that manufactures two different styles of tables. That's all they do at this factory. One table is in a country style, and the other one is a contemporary style. When the table is manufactured and sold, the company will generate a selling price for that table as listed here. So the country table will generate a revenue of $350 per table, and contemporary will generate $450 per table. Now, if our goal as a company is to maximize the revenue, then we can set up formulas. So you can see here we have a formula called the sum product statement, which is basically the equivalent of taking whatever I put into this box, multiplying it against this, and then adding it to the total of the same calculation in this column. So multiplying this times that. And that equation is actually represented right here in this table. And so what we're trying to do is we're trying to maximize the total revenue relative to how many tables we are going to create. So X1 is country, X2 is contemporary. And this is a very typical type of equation that a business manager would look at. Now, if you would ignore all these things at the bottom, right? So if you're just looking at the top equation, well, this is a really easy answer. If you want to maximize your revenue, you make a whole bunch of this one because this one generates more revenue, right? They'll just I'm just going to make that table. Why would I even bother to make the other one? Well, here's the why. You might get orders in that require you to make the other one. That's one reason why. Um, then the other thing that you have to consider is that these other aspects, what we call resources or constraints, are limited. So I don't have an unlimited amount of resources to make any one type of table forever. Okay. Each one of the tables will require access to production equipment. So, for example, the country table requires 1.5 hours of router time, uh, 3 hours of sander time, and 2.5 hours of polisher time. Contemporary uses these figures. Now, these figures are limited. So each table takes that amount of time, but I only have this many machine hours available in my production period, whatever that is, a week, a day, what have you. Okay. And so I can't exceed those limitations. They're set by how long it takes for processes to run through the machine, how many labor hours I have attached to it so people can operate the machines, how many shifts I'm running, all that is calculated into that. So I can't exceed this many production hours on any one of the machines. And so once again, this field here contains a variable that basically will be determined by cross multiplying the number of tables we make by the machine production time, adding it to the other table's machine production time, and then keeping that total production time less than what's completely available. Now, so I want you to think about all these little things, right? So if I, for example, create one country table, I can just manually type this in. I have 350 in total revenue. If I create one of these, it automatically does that. But notice how it also impacts all these other calculations. So all of a sudden it's like, well, I've just consumed some of these resources. All right. But these two variables drive the whole thing. So the real question is, how many of each do I make to maximize this while keeping all of these constraints within their limitations? And then on top of it, we have this other limitation, probably, something from management that says at least 20% of your production needs to be this table type, and 30% of the production needs to be this table type at a minimum, because we know we sell, that relative portion. All right. And so on an equation basis, we have these shared set of variables, x1 and x2, that sit in every equation. And we read this as we're maximizing this, which is profit, by the way, subject to or such that, people will read it different ways. We keep the router time, the sander time, the polisher time all under control. Each one of the table types stays within the minimum production limits. And then the other thing that we have here as an issue too is we have to make at least none. Can't make less than none. So that's an issue. So we have to make at least 0. We can't use negative numbers here. And so this is actually really what we call an interrelated linear programming mathematical model. So these are all linear equations in algebra. And the reason they're linear is there's no exponents or square roots or cube roots or anything like that, or negative exponents. So all of the equations, if I put them on a Cartesian coordinate system, a chart, they would plot a straight line. But all the straight lines interact, right? And depending on the values that we put into x1 and x2, which are x1 and x2 on our chart, these can all have different values. And you can see how you just type one number in and you keep going. And then, of course, really the grand goal is to try to utilize all those resources as fully as we can and maximize the revenue at the same time. Now, as a human being, we could speculate. I could just say, hey, what if I made like 100 of these and 100 of these? Okay, I still have a lot of unused resources. See, a lot of unused resources. All right, let's triple that. 300 of these and 400 of these. And now I see, I'm exceeding my limits. But I'm getting closer to where they sit. But to find the right product mix, I would have to sit there and just type numbers endlessly until I could figure it out, right? That could take a while. And some people would sit and mathematically try to figure this out. And if you want to try to solve all these equations simultaneously, be my guest, right? So what Solver brings to the table is this. You can click on this chart, and I want you to notice how it works. The objective is cell E5, which is the result of this formula, so the total revenue. We're trying to maximize it by changing the variable cells, these two, subject to the constraints where all the machine time is within its constraints. That's the first equation. We make at least 0, and that the minimum amount required is within the range that we've declared. We select the type of equation we're working with, which is a linear programming LP problem. We hit the solve button, and then in the background, what we're doing is this just went through a whole series of permutations. And it gives back this whole like message and stuff, but ultimately this is the correct answer. So what this figured out is if we want to maximize our total revenue, stay within all the available limits, this is the correct product mix in order to satisfy that objective.
And then you just round it to the nearest actual table, and then
Yeah, and from a production standpoint, because these resources are limited and one of them is at the limit, we would round down. So we'd make 405 and 173 is what a production manager would choose based on this data. Now this is an example using 2 tables and 3 sets of resources and a couple of other constraints. Could you imagine if you're in a factory where you had 10 machine processes and 40 products and other minimum required production amounts and all this data, and how complex that equation would be and what that would look like as an equation? This is just 2 products. But here's the thing about it. You can, if you have the right data, you can map it all out mathematically, plug it into Excel like this, run a tool like Solver, and you saw how fast it did it. It's like literally like a second or two. It's running through thousands and thousands of permutations of possibilities until it finds what it considers the optimal solution.
it took longer for you to select the OK button than it did for it to do it.
You got it, and that's a way to look at it. So this is what Solver brings to the table on a professional level. Now, this example that I'm giving you is from one of the MBA classes that I used to teach. So this is like graduate level coursework, you guys, when you do this type of programming. And so some engineering, business, and science tracks have specialized math courses called linear algebra or LP programming. And this is what it's about, by the way. This does have a role in data analytics, obviously. I would consider this pretty high-end stuff. And you don't have to operate on this level, but I do want you to be aware of it so that when you walk into a situation, you can intelligently talk about it with somebody, even though you might not be an expert at doing it. The expertise comes later, frankly. But seeing how it works and knowing that this capability is available is pretty powerful in itself. So that's Solver, folks. And I'm going to end this recording here, and then I will make a separate one for later tonight.